large cities make social distancing very difficult to achieve because people need to move freely around the city and the cities are usually overcrowded. So we need to build in a new architecture of the city that allow people to move freely without risk to their health and lives and the lives of the other people. So the way how to achieve this, we will build this new four-layer architecture, which has two components. One is in the communication service provider and another is in the city government. So from the point of view of a city government, city behaves almost like a real-time social graph. This allow also run things such as the prediction services and also get the inference to optimize the machine learning models. City also has something which we call control plane, allow the city API services to be enabled. And we also split a city not just in the areas, but also the edge locations. So places like museums, hospitals, and it could be even the things like public buses and so on. And then we have a registered entities, which is the blockchain hash, and therefore we do not disclose any personal information, as you will see next. And then we have alert systems that basically allow people to, for example, warn not to enter to certain areas or to certain edge locations. This is the reason why we have a communication service provider in place, because a communication service provider is the owner, let's say, of this infrastructure. And the reason why we're doing it because we specially designed for Europe, so to be GDPR compliant, including things like right to be forgotten and so on. So what we do, as you can see on the next slide, we have the blockchain record, which we call identity hash. And the identity hash is basically the consensus between the device and the identity of the person and the government identity, bank identity, and also the health status, which could be the person is a COVID risk patient or there is a COVID negative. And the result is the hash. And basically, we do not work with the physical people here from the API perspective then, but we created the blocks, and these blocks are actually what's going to be initiated by the other systems. So there is no way how you can go back and find out what is the person behind this hash. Okay, so as you can see in the ledger, we have the someone who is a COVID negative and there is a someone who is a COVID positive, but you do not have the way to deconstruct the real person behind it. So in this slide, we can see how we actually going to be use those data which we captured in the previously. As you can see, the edge locations are marked as triangles. It could be places like museums, airports, railway stations, large shopping malls and all that. And then we have a city split into the areas. So it might be the quarters and all that. And they all have different policies that you can apply to them, or they could be citywide policies. Plus, we have the blue dots, which is representing the people that are COVID negative. And then we have a red dots, which are representing the people that are risk people. For example, that might be the COVID positive. And as you can see, there's a real-time graph, which is actually showing how the people moving around the areas in the city and those edge locations. And therefore, we can use a machine learning predictions and basically, for example, send the proactive alerts for the people that are actually in the area 8 not to move to the area 14 because there is a high risk of contagion.